Okay, so can you hear me okay? The backside? Yeah, okay. So firstly, thank you so much for joining in. This is one of my first meetup in this side in the in San Francisco. It's always crowded, but it's fantastic to see a lot of people here during the weekdays. Okay, so how many of you are coming from a software engineering background? Oh wow, okay, almost 50%. How many of you are from research or let's say machine learning side of things? Okay, very few. Okay, so what I'm going to do in this case is we'll try to focus more on the first part, defining what ray is. My idea is in 20 minutes or 30 minutes, you get something out of this. So, and then in the last part, I'll just share a few thoughts on how this new AI stack looks like in today's time. So, what is Ray? Ray is an open source framework or open source engine that you can use for distributed compute. Okay, so what does that mean? So you can think of Ray as a unified layer which can distribute your application across multiple GPUs and multiple CPUs. If something is working on your laptop, now you want to deploy it and you want to deploy it in 10,000 machine, Ray can make sure that it can schedule it in the right way. Okay, but this is very much native. That means that when you get started, you can just do pip install, and what you get inside is a Ray core, which is the core engine of Ray. There's nothing about AI. We are saying this as it unifies the AI ecosystem because this is meant for AI workloads that we will come back later, but at its core, you can just scale any application. So let's see how it works. But before that, when we say it is, you can just do pip install. After that, you can make your laptop as a cluster with, let's say, 8 CPUs. If your laptop is having 8 CPUs, you have a cluster of 8 CPUs. But you can take the same code and use it on any of the cloud providers, and you can just scale your applications. It's very much agnostic to the underlying hardware. Now, how does that work? So let's say this is a Python application. We have two functions, and we are just calling the first function, getting the value, calling the first function again, getting the value, and then we are doing something in the last part, which is a similarity search. We don't have to worry about these functions, but if you run this on your laptop, this will run in a single thread sequentially. Now, how we can make it scalable? We can just decorate it with Ray remote, and now this becomes a Ray task. And what happens is now the way that you will call this function is by calling .remote. It will not return the value, it will just return a pointer, and under the hood it will continue the execution. That way, what can happen is your first function call might run in some of the CPU in your machine. The other function can run on some other CPU in your machine, and this can work once they get the result in some other CPU. And you can define that this should run on CPU or this should run on GPU and all of that. We have not mentioned anything, but when you mention it here, let's say in the parameter, you want GPU, it will just run on the GPU, right? So that's the granularity that you get, not at the Python function, Python file layer, but inside your function. Okay, but this is very much stateless, right? Because we are just running it independently. There is no state. That's why we say that this is what we have here. It's stateless. If you want to do it anything stateful, it is the same thing, but in place of functions, you will decorate it as at the class layer. Right? So that's the only difference. So all your state would be in this constructor. So this will not be loaded multiple times. Use cases are, let's say you want to generate embedding. You don't want to load that model every time to generate the embedding. So that would be stored, in the init. Or let's say you are doing model training. You want that model training to be synchronized, right? When you do the back propagation and all that. So you cannot just do independently. So that is how you can scale any application in Python using array. Now, the only thing that to remember is you can convert your functions to Ray task, classes to Ray actor, and that's how you can scale your application with Ray. So now this is good, but what the team thought is, one can do this for anything, right? Nothing to do with AI workloads. But they thought that there are different AI workloads which has a definite APIs, especially for serving or inference, reinforcement learning, training, tuning, data processing. If you have heard of these frameworks like Pandas, NumPy, right, these all have very similar semantics. So what they thought was, they thought that, okay, why can't we just create a higher level library for all of this so that they don't have to decorate their function like you can always do, like the way that we have just seen. So you can think of these AI libraries are higher level abstraction where you don't have to create that decorator, but you can just simply use their API, just like how you use Pandas, NumPy, PyTorch, and engines like that. And under the hood, it will create those tasks and actors based on the requirement. Does that make sense? Yeah. So that is what these AI libraries are, and it has a support for other engines as well. And to get started with those, you can just install those libraries as you need. Now, it has an integration of VLM, PyTorch, TensorFlow, and all of these frameworks in this ecosystem. Now, if you think about why we are talking about Ray, if you go back and see the history of Ray was created by Ion Stoica, Robert, and Philip in UC Berkeley. So Ion Stoica is professor. Have you heard of his name, Ion Stoica? Yeah, so yeah, he's a very prominent figure in computer science. So he and his students created Spark in early 2008 or 2009, which later on became Databricks. In 2016, he started, along with two of his other PhD students, this project Ray. And the initiation of this project was they were trying to train an RL model, and they were not able to scale beyond their laptop, and they were finding it very, very hard. So then they started thinking of how we can build a tool or a platform which can help them to scale their RL algorithm. That was the premise. And that's why RL was the first library that they have created on top of Ray core, and that became Anyscale later on. But now, if you see, Ray has become a thing after, I think, last 2-3 years, when ChatGPT, GPT-2 was trained on Ray, then few of the other front-end models. And what today's workload demands is heterogeneous hardware usage for your data, right? You think of ChatGPT. When it came, we were able to ask questions, just text. Today, you can upload a recording, upload a video, YouTube, whatever, right? So that means what? Previously, it was very, very much segregated. You need GPU for inference, training for GPU for training, post processing for CPU. But today, if you see, even the pre-processing needs GPU, right? So when you use, let's say, RAG, have you heard of RAG in any of the agentic application? You will see that you have to create the embeddings of your query. So when you create the embedding, you need to load the model and generate that. Right? So for that, you need some GPU. So nowadays the workload is very heterogeneous. So that's why Ray fits in this kind of workload where you need more fine-grained application or workload aware resource allocation. Right? So that's what Ray supports. And this is the trend that we are seeing in the recent past. If you see, all the models today are reasoning-based model. Right? You might have seen this, right? When you give a prompt, it says thinking, right? So it reasons. So all the model providers, they are based on RL, and all this engine which supports those model training are using Ray under the hood. Okay, so since this framework started with RL, and at that time RL was not the thing, but in the last 2 years, RL became a thing, so Ray became a thing. So that is how I can map, right? Otherwise, they were quite ahead of time, but it was just that the market was not fit for that. Okay, so that's about Ray, semantics and all. So now the last part is how we look at this in today's time in terms of the AI stack. So in today's workload, we have agentic AI, post-training, data processing, and all of that. And in the bottom, we have the hardware. So you can think of AWS, GCP, or any cloud provider, or even you can go below any of the GPU from NVIDIA, AMD, and all. So between these two, there is a stack of things. It's very, very complicated. If you have worked on distributed systems, it's very, very hard to scale all these workloads. And the scale that we are talking is not 10 machines or 100 machines. It's 10,000 machines, 20,000 machines. So I was just working with one of our customer, and what is that company name? Claude, but not Claude, sorry, Cursor, but the company name is something different. But they were looking for fault tolerance for one GPU in the cluster of 20,000 machines, and they want to read the checkpoint only for that one GPU, not across a batch of GPUs. So it's a very complicated stack, and we need to think about scheduling, hardware failure, etc., etc. And all of these workloads demands different type of resource in the middle. So that's why if you think of this stack, the top stack would be it's kind of dominated by PyTorch and JAX, but predominantly PyTorch. And this is used for both training and inference. And using PyTorch, there are a lot of different libraries that we have, like VLLM. Have you heard of VLLM, SGLang, right? So these are all transformer-based optimized engine, and these all work with PyTorch. And there are few which are generic, like FSDP for distributed training, DeepSpeed. They all are different techniques or engines for doing distributed training at scale. But these all comes under the umbrella of PyTorch. And then we have this distributed compute engine like Ray or Spark. Spark is mostly for data processing, which is mostly for CPU and structured data. And then you can always have your own custom engine. And between the hardware and Ray, you can always run Ray, Spark directly on the hardware. But to make better use of the resources, you will use some orchestration like Kubernetes. So Kubernetes is very good to allocate your resource at the pod level or the container level, right? They don't have any idea what is happening inside that container, what is happening inside my code. So what people generally use is they use Kubernetes for finding the right resource, or in the form of pods or containers, and then they use Ray to have even fine-grained access to the CPU and GPU within that pod for different AI workloads, be it data processing, post-training. When I say post-training, you can think of it like fine-tuning or anything like that. So if you see, predominantly, this is the stack, and this stack is evolving, right? Every day something new is coming. In fact, all these libraries, like a VLLM is just 1.5 years back, 1 year back. SGLang is just a fork of that, and they are solving a different problem. But these all are just 1 year, 2 year old. And predominantly, this is the stack that we see. It's PyTorch, Ray, Kubernetes. And when I say we see, like most of the customers or developers in the open source side are building things using this stack. And that's why we kind of see this as a park stack, like PyTorch AI. It's a marketing term, but I just liked it for some reason because there is some stack called Lamb stack, right? So I was just talking to somebody in the industry who's like Ben Stoica, so he was comparing this with Park Stack, and you can see the growth of Ray adoption. This is the time when ChatGPT came, and this was the download, right? I have no clue what they were doing during this time, but yeah, they were surviving. So yeah, so I think from this time onwards, when the chat GPT came and that became a thing, and from this time onwards, you can correlate, right? These are the signals that you can get. There's a time when deep speed came, and deep speed opened up the architecture of reasoning based model, right? And that's when all this KV cache, mixture of experts, reinforcement learning, everything came up, right? There, and after that, all the models that you see today, all reasoning based, and everything needs uh, an engine which can manage your resources based on your workload. And that's why we see a kind of a hockey stick growth in Ray. I'm not very sure about the adoption, but at least on the download, right? So but surely there's something that you may like to look into. But again, this stack is evolving. My idea here is just to share that if you want to scale any application, be it a Python application or an very specific AI workload, you may like to just install it on your laptop and give it a try. And as I said, we have seen these frameworks, engines working together like VLM and Ray, Kubernetes with Ray, and things like that. So at the end, these workloads are getting complex and complex. It needs different hardware, and hardware complexity are also increasing. If you see this, 3 years back, it was just NVIDIA who was building GPUs. I was with Amazon for 6 years just before joining. We have been using NVIDIA GPUs, but after 2022, the company took a very strategic decision that we have to build our own chipset. That's why you see that none of the model today, which Amazon is training or using, they run on they do run on NVIDIA, but they have their own Trainium chipset. Similarly for Microsoft, similarly for Google, they have TPUs and all that, right? So the point is, every new hardware that is coming, you need to make sure that your software stack is enabled to make use of any of these hardware, any of the vendor, and open source is surely one way to go, right? So that's all from my side. If you have any questions, feel free to ask. I'll be around, and if you have any questions, just send me a text. I'll be happy to answer. Thank you so much.